All right, let's get started with 5-4's worksheet, sum and difference formulas. So we're going to add a few more formulas to our toolbox here. And so we're going to say, all right, we've figured out what to do if we know the sign of 30 or 45 or 60. But what if we want to come up with a formula for an angle that's maybe 30 plus 45 or 60 plus 45? And so we've got these formulas here. One for adding sine, one for subtracting sine, one for adding cosine and subtracting cosine, and then one for adding and subtracting tangent. And so you'll notice the sine formulas, a couple things in common. If it's an adding, we'll add in the middle, and it's one of sine and one of cosine, and then one of sine and one of cosine with the alternate angles. If we're subtracting, we subtract. But then when we go to cosine, it'll be the opposite, minus and plus for the minus formula. And notice cosine starts cosine, cosine, and then sine, sine. And then when we go to tangent, it's all tangent in the formulas here. It's got a fraction, tangent plus tangent on top, and then 1 minus multiplying on the bottom. If it's a minus, we'll minus on top and add on the bottom. Start to remember these. All right, so we'll use the sum and difference formula to find the exact value of tangent 255. So 255 is not something that shows up on our unit circle, but since it says exact, we're not going to use our calculators either because we don't want any decimals. We want the fraction values. So we have to figure out some way to use the numbers we know that are on our unit circle to add to 255. So there's a few ways to do it, but one of them is saying instead of tangent of 255, I can comprise 255 of 210 plus 45. And 210 and 45 are both numbers that I know. 210 is in quadrant 3 with a reference angle of 30 degrees. So it's just going to be, if we look at our chart, the same as tangent of 30. And it'll be a negative over a negative, so our sign won't change either. So tan 210 is exactly the same as the tangent of 30. So let's go ahead and find our formula for adding. It's tan u plus tan v over 1 minus tan u tan v. And so we'll plug in our values. The u, the first angle we see, is 210, tangent of 210, plus the second angle, v, is 45, over 1 minus, and then we plug them in again, tan 210 times, this time, tan 45. And so we go to our chart and we check this out, and the tangent of 210 is root 3 over 3, minus the tangent of 45 is 1 over 1 minus tangent of 210 again is root 3 over 3 times 1 this time. And so we'll subtract here. I'm going to cross this out and make it 3 over 3. So we have a common denominator. So we'll have root 3 minus 3 over 3. Big dividing. 1 minus root 3 over 3. Let's cross this out also and make it 3 minus, and that should be a plus. Didn't bring it down properly. 3 over 3. All right, so let's flip it over here and do multiplying by our reciprocals, root 3 plus 3 over 3 times, if we flip this over, 3 over 3 minus root 3. Those cancel. Root 3 plus 3 over 3 minus root 3. All right, here's where things get a little tricky, but not too bad if we remember our algebra. To get rid of a 2-term on the bottom that has a root, we want to multiply by the opposite sign. So we'll go 3 plus root 3 over 3 plus root 3. And we'll FOIL everywhere. So on top, we end up with 3 root 3. Outside, plus 3. Inside, plus 9. Last, plus 3 root 3. Over. Let's FOIL again. First, 9. Outside, plus 3 root 3. Inside, minus 3 root 3. And last, it'll be a minus 3. Cancel and cancel. We have, what do we have here? 12 plus 6 root 3. Erase this to create a little bit of space. 12 plus 6 root 3 all over 6, which equals 2 plus root 3. All right, a lot of algebra work on this, but it all stems from that first formula. So we're going to be plugging it in. Let's try one more. Find the exact value of cosine 95 cosine 35 plus sine 95 sine 35. All right, so we're going backwards here. We're trying to find which formula this works with. Notice it's cosine cosine to start, so this must be a cosine formula. Since it's plus in the middle, when we look at the formulas, that means it must be u minus v. And what's our u and what's our v? It's the first angles we see, 95 minus 35. So this is the cosine of 60 degrees, which we can check our unit circle or our chart and come up with just 1/2 as our answer. All right, so we're going to move on to reduction formulas. And a reduction formula is an expression involving only sine or cosine that is derived from the use of sum and difference formulas to rewrite expressions, such as sine theta plus n pi over 2, or cosine of the same thing where n's an integer. Basically what this is saying is when we have those multiples, right, 3 pi over 4 plus 2 pi n, repeating, 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 we want to be able to break these down. So anytime we see a plus inside the parentheses, we can use the formulas that we got on this chapter. So let's try one. Sine of t plus pi over 2. We're going to use our sine sum formula. So this is sine of t cosine of u plus cosine of t sine of pi over 2. Getting that right from those formulas at the beginning of this worksheet. So let's solve or simplify where we can. The cosine at 90 degrees is 0, and the sine at 90 degrees is 1. So 0 times that goes away, and our answer here is just cosine t. Forgot my t up there. All right, so we've simplified down and just end up with cosine t, a much simpler answer than what we started with in our problem. Let's try one more example to wrap things up here. Let's find all the solutions of cosine x minus pi over 3 plus cosine x plus pi over 3 equals 1. All right, so we've got 2 substitutions to do. We're going to start with this one. It's a cosine minus problem. So I'm just going to start over here and simplify it all the way down. This is cosine x, cosine pi over 3 plus, remember opposite sine for cosine, cosine pi over 3. Sorry, not cosine. The second half is sine. Let me erase that. And just to make sure we're matched up. Order doesn't really matter with the multiplying, but let me make it look good here. Sine of x sine of pi over 3. All right, so we'll figure this out. The cosine at 60 degrees is 1/2. So we have 1/2 cosine x plus root 3 over 2 sine x. All right, so that's our first half. We're done with this one. Let's get the second half, cosine of x plus pi over 3. That's cosine x, cosine pi over 3, minus sine x sine pi over 3. All right, so let's simplify again. Cosine of pi over 3 is 1/2. And root 3 over 2 sine x. And we've got a big plus sign in between these two, so we'll put them together. And let's simplify. Positive and a negative go away. 1/2 plus 1/2 is 1. So we have 1 cosine x equals 1 from the other side. So cosine x equals 1. And where does cosine x equals 1? There's only one place on your unit circle, and that's at 0 degrees, or 0 radians. And we would say plus 2 pi n, but this is saying we only want the answers that are in between 0 and 2 pi. If we added 2 pi, we could say 0 and 2 pi are our answers, but notice the parentheses here. We're saying below, not equal to 2 pi. So can't use that. 0 is the only answer that's going to work in the range described.